right, so this is the little video to describe how to solve problems 8 and 9 on the Phet worksheet for isotopes. And what those two questions are asking you to do is to find the average atomic mass for each of those particular isotopes using the relative abundance of each of those isotopes. And when we say relative abundance, it's what percentage of that isotope is currently found in our universe. So here we can see that 5.845% of all the iron, all the Fe we know about in the universe, is of type iron 54. Now, the relative mass for that is really close to 54, but it's not going to be a whole number because masses are hardly ever whole numbers. So it's 53.9396, which is really close to 54. And three other isotopes make up the abundance in the universe for iron. The predominant isotope is going to be iron 56, 91.754%. And then there's some trace isotopes as well. The goal for this is to use all this information to come up with the average atomic mass that you will find on your periodic table. So to do this, the first thing we go ahead and do is we change the relative abundance into a decimal. And to do this, we divide by 100. Dividing by 100 can be done a real short way by moving that decimal place 2 places over to the left. So for the first isotope, which is Fe54, it's going to have a relative abundance of 0.05845. And I can times that by the atomic mass units, which is this one right here, which is going to be the 53.9396. And I'm going to repeat this process with all 4 isotopes. So my next one is iron 56. Move that decimal place 2 places over to the left, which means divide by 100, which is going to be 0.91754 times 55.9349. Next one is iron 57, and it's going to be 0.02119 times the 56.9354. And last but not least is the one that appears the least in nature, which is going to be iron 58. And iron 58 has an abundance of 0.00282. And we're going to times that by 57.9333. So now the next thing we're going to do is we're going to do some math. And I'm going to grab my calculator here and just go ahead and plug these in. And when I plug these in, what I'm figuring out is the mass that is going to contribute to the overall atomic mass for that element and what we find on the periodic table. So 0.05845 times 53.9396. So the first one here is going to be 3.15. And, I'm just going to do 3 decimal places. I don't care how many decimal places here. I like 3. It's just a rounding issue for this particular assignment, so I don't care how many decimal places you go out to. 0.91754 times 55.9349. So this is the big piece that is contributed to the atomic mass on the periodic table. 51.323. The second to last one, 0.02119 times 56.9354. This one is only giving 1.206 AMUs to the total mass. And the least abundant iron 58.00282 times 57.9333, 0.163 AMUs. And yes, I keep on saying all of these units are atomic mass units. They're just a way to measure the really small mass of these particular isotopes. So my last step here is just to add them all up. So if I add these all up, I will get a mass that should be the exact or really close to the mass that you find on your periodic table. So 3.153, 51.323, 1.206, and 0.163. I get a number of 55.845 AMUs. And I bet you if you look on your periodic table, the mass that you find for iron is going to be really close to 55.9 AMUs. So it's going to be a little bit off because every periodic table is made a little bit differently by different publishers that might have different information about the relative abundances of each of those isotopes. So if they're a little bit off, it's because they have different percentages than you did. It doesn't mean you're wrong, doesn't mean that they're wrong. It just means that it's different information at a different time. To double check any of these questions, after you solve your math, you check your answers to the element on the periodic table. And if you're close, you're right. If you're far off, you did something wrong with your math. So hopefully this made sense to you and helps you with the other two questions on there. And we will review this at a later date as well. Thank you for listening.